The fundamentals of Six Sigma, Pareto analysis, the 80-20 rule. Pareto diagrams are very specialized forms of column graphs. They are used to prioritize problems or opportunities so that the major problems or opportunities can be identified. Pareto diagrams can help Six Sigma teams get a clear picture of where the greatest contribution can be made. History. There is a very interesting story behind the name of the Pareto diagrams. The word Pareto comes from Vilfredo Pareto, 1848 to 1923. He was born in Paris after his family had fled from Genoa, Italy, in search of more political freedom. Pareto, an economist, made extensive studies about the unequal distribution of wealth and formulated mathematical models to quantify this maldistribution. He also wrote a political book on nationalism, which helped lead to fascism in Italy. Dr. Joseph M. Juran, world-renowned leader in the quality field, was preparing the Quality Control Handbook in the late 1940s. He needed a short name to apply to the phenomenon of the vital few and the trivial many. He depicted some cumulative curves in this manuscript and put a caption under them, Pareto's Principle of Unequal Distribution. The text makes it clear that Pareto only applied this principle in his studies of income and wealth. Dr. Juran applied this principle as a universal. Thus, the diagram could be named a Juran diagram. To complicate matters more, the cumulative curve diagram itself was first used by M.O. Lorenz in 1904. Briefly stated, the principle suggests, in most situations, that a few problem categories, approximately 20%, will present the most opportunity for improvement, approximately 80%. Pareto diagrams are used to analyze a problem from a new perspective, focus attention on problems in priority order, compare data changes during different time periods, provide a basis for the construction of a cumulative line. The fundamentals of Six Sigma, basics of Six Sigma metrics. What is a unit? An item being processed. What is a defect? Failure to meet a customer requirement or a performance standard. What is an opportunity? Any product or service characteristics which are measured to a standard. What is defective? A unit that has a defect. What are defects per million opportunity? The number of defects that would arise given a million opportunities. DPU, DPO, and DPMO. Defects per unit is DPU. DPU equals D divided by U. D equals total number of defects. U equals total number of units. Defects per opportunity is DPO. DPO equals D divided by U times O. D equals total number of defects. U equals total number of units. O equals opportunities for defects per unit. Defects per million opportunities, or DPMO. DPMO equals 1 million times DPO, equals 1 million times D divided by U times O. Yield. Different types of fulfillment can impact the quality level we measure in our processes. Yield can be understood as follows. Classical yield. Classic yield, or YC, minus units passed divided by units tested. First pass yield. First-time yield, or YFT, minus units passed divided by units input for first time. Rolled throughput yield. Rolled throughput yield, YTP minus yield 1 times yield 2 times yield 3 times yield 4. Cycle time. Cycle time equals 1 divided by throughput rate. Performance measures. Effective business process management, or BPM, requires an integrated system of metrics in order to achieve the desired Six Sigma business improvements. The system of metrics should provide monitoring and control of each metric at each level of the business, as well as identify the linkages needed to discover the key relationships of KPIVs to KPOVs across the entire system. It should facilitate the collection of data and building of summary information from detailed parameters, that is, temperatures, voltages, or dimensions, at the process level to customer and manager parameters, that is, DPMOs, yields, and throughputs, at the operations level to market and financial indicators, that is, profit, growth, and market share at the business level. A closer look at each level reveals the kind of measures and sampling strategies required for an effective Six Sigma process. Business-level metrics. Business-level metrics are typically financial or external and operational or internal summaries for shareholders and management. Kaplan and Norton introduced the balanced scorecard for business-level management metrics in the following areas: financial, customer perception, internal business processes or operations, company learning and growth, employee satisfaction, sometimes added as a fifth category. The true purpose of these metrics, when he refers to them as satellite metrics, is the highest level measures in business process management. Business or executive level metrics comprise summaries of detailed operations and financial results reported monthly, quarterly, or annually. Traditional end-of-period cutoff reports are not sufficient for Six Sigma projects. Other standard reporting practices, such as comparing year-to-date totals to the same period last year, are also inadequate. It is important to remember that these metrics are part of a complete system and should be treated with the same statistical process monitoring and control techniques as operations data. Operation-level metrics. Six Sigma provides new metrics for managing complex operations. Business effectiveness measures track how well products are meeting customer needs, or external focus. We can call them 30,000 feet metrics, indicating that they should have a longer-term perspective and reflect the total variation that the customer sees. Operational efficiency measures relate to the cost and time required to produce the products. They provide key linkages between detailed process measures and summary business results, and help identify important relationships and root causes. The employees and teams who can see the impact of their efforts on the overall business outcome learn and make improvements more effectively and efficiently. Six Sigma project financial measures will be described in more detail later this section. Process metrics. Detailed process-level metrics include data from production people and machinery. This is the information that operators and supervisors need to run normal operations. This information is also the subject of much of the Measure, Analyze, Improve, and Control phases, or MAIC, of Six Sigma, once the improvement project has been selected and defined. Measurement system considerations. Some recommendations for effective process performance metrics for the modern enterprise include the vital few versus the trivial many. Large organizations may have hundreds or even thousands of metrics, but no individual should have to focus on more than a few. Overall business-level metrics should be less than 20. Metrics should focus on the past, present, and future. Past history provides context for decisions and builds organizational wisdom. The present data provides real-time process control. Future predictions provide the basis for estimates, improvement plans, and strategies. Metrics should be linked in a systematic way. Metrics should be linked in a systematic way to meet the needs of shareholders, customers, and employees. Have multiple metrics. The key to an effective system is to have multiple metrics, not just one important one. Success is about balance, not a mindless focus on quality, shareholder value, profit, or any other individual measure. Metrics linked to shareholder needs. Metrics should be linked to shareholder needs at the business level. Metrics linked to customer needs. Metrics should be linked to the customer needs on the operations level. Metrics linked to employee needs. Metrics should be linked to the employee needs on the process level. Metrics to be consistent. Metrics should be consistent for all levels of the organization. Combination of multiple metrics. Multiple measures can be combined or aggregated into overall indices of performance for higher levels. Evolving metrics. Metrics should evolve as strategy and situations evolve. Research-based metrics. Metrics must have targets or goals based on research. Six Sigma improvement methods help establish improved goals. Summary: the fundamentals of Six Sigma. In this session, you learned about the following. What is the definition of a process? What are critical to quality characteristics, or CTQs? What is cost of poor quality, or COPQ? What is a Pareto analysis, or the 80-20 rule? Which are basic Six Sigma metrics?